To see where the second expression comes from, the one with the cross product of r prime and r double prime, we're going to start with what t, the unit tangent vector, represents. I'm going to drop the parameter t. You know that it's t of t, but it's easier to write all this without that. The unit tangent vector is r prime divided by the magnitude of r prime by the definition of the unit tangent vector. And as I just alluded to, the magnitude of r prime is also called ds dt, how the arc length changes over time. Taking the first equation and clearing the fraction will give us that r prime is equal to the magnitude of r prime times t. But we've just said that the magnitude of r prime is called ds dt. So r prime then becomes ds dt times the vector, unit tangent vector t. Then r double prime, the derivative of r prime, is going to use the product rule. We have d2s dt2 times the unit tangent vector t plus ds dt times t prime. Crossing r prime with r double prime will then give us ds dt times t for r prime cross d2s dt2 times t plus ds dt times t prime. Using the distributive property of the cross product, remember the cross product distributes over addition, we can express this as ds dt times d2s dt2 times t cross t, that's the unit tangent vector crossed with itself, plus ds dt, the quantity squared, times t cross t prime, that's the unit tangent vector crossed with its derivative. We're going to pause here to recall two things. Number one, when we saw the cross product in an earlier chapter, we saw that a cross b in magnitude is equal to the magnitude of a times the magnitude of b times the sine of the angle between them. And it follows that if we cross a vector with itself, t cross t, theta is equal to 0, which means that the magnitude of t cross t is equal to 0. So t cross t itself is equal to the 0 vector. So that's the first thing I'd like to recall. The second thing is a little more involved here. Recall that if the magnitude of any particular vector is a constant for all t, then that vector is orthogonal to its derivative, right? So if the magnitude of r is constant, then r is orthogonal to r prime for all t. Since the magnitude of the unit tangent vector is 1 for all t, the magnitude of, not the magnitude, t is orthogonal to t prime, which means that the angle between them is pi over 2. So the magnitude of t cross t prime is equal to the magnitude of t times the magnitude of t prime times 1, the sine of pi over 2. So let's back up a little bit. T is orthogonal to t prime. We have t cross t prime up here in our cross product. They are orthogonal to each other. To come up with an expression for the magnitude of r prime cross r double prime, we recall we have t cross t here, which is going to be 0. And so the magnitude of r prime cross r double prime is simply going to be equal to ds dt squared times the magnitude of t cross t prime. But based on what we said about t cross t prime, we have the magnitude of t, which is 1, times the magnitude of t prime times 1 for the sine of theta. So r prime cross r double prime in magnitude becomes ds dt, the quantity squared, times the magnitude of t prime. Solving for the magnitude of t prime, we get that that is equal to the magnitude of r prime cross r double prime divided by ds dt, the quantity squared. The denominator is also written as r prime of t squared. So back to where we've already been. Where was it? Here it is. Kappa of t is magnitude of t prime of t divided by r prime of t. That's what we called expression 1. Did I say magnitude of r prime of t? I meant to say magnitude of r prime of t in the denominator. So still dropping the argument t, kappa, which we said was equal to the magnitude of t prime divided by the magnitude of r prime, then becomes, based on what we just discovered, the magnitude of t prime represents here, r prime cross r double prime in magnitude divided by r prime cubed. And that gives us expression 2. For expression 3, I'm not going to give you the whole thing, I'll just give you a roadmap. If y is equal to a function of x, then we would use x equals x as the parameter. Then we would express the curve r of x as xi plus f of xj plus 0k. And then you can find that the magnitude of r prime cross r double prime turns out to be the absolute value of the second derivative of f. I will leave that to you.